analogia com a tecnologia clínica alergia, nós, dentro da nossa tentativa, cada vez mais funcionarmos como departamento, não só como disciplinas isoladas, aqui a nossa chefe do departamento, hoje, nós estamos presentes no nosso seminário. Já tivemos várias discussões com o nosso convidado, que é o Dr. Matias. Nossa intenção é ver também se a gente consegue, em meio de um centro importante, se a gente consegue desenvolver projetos em colaboração com ele. Ele tem uma visão crítica muito boa, ele também é editor de várias revistas, sempre bom a gente conhecer os editores de revistas, facilita um pouco a nossa vida. Pelo menos eles saberem que a gente não é tupiniquim que não está em cima de árvore. Que existe laboratório que dá suporte para as coisas que a gente está fazendo. Eu conheço o Matias há muitos anos, ele parece bem mais jovem, mas não é tão mais jovem assim aqui, né? O Incor me judiou aqui um pouquinho. E o Matias, ele é uma autoridade em doenças autoimunes e ele se dedica agora muito mais à diabetes, à compreensão dos fenômenos intrínsecos da imunologia da diabetes, como é que as viroses desencadeiam o processo e como é que a resposta, a modulação da resposta imune pode influenciar no desenvolvimento, na manutenção da doença. Então ele é bastante conhecido, isso é internacionalmente, e a ideia dele é que ele efetivamente tenha colaborações conosco, tanto na área de diabetes como em outras coisas que a gente faz aqui. Tem várias ideias, tem outras infecções. Nós trabalhamos com HIV também, tem várias ideias a respeito. Também nós temos choque térmico, como é que nós trabalhar com tolerância. E acho que é importante ter um contato com ele e fazer com que ele venha até mais vezes aqui para esse intercâmbio internacional. Matias, thank you very much for coming. It was a great pleasure. I speak the worst thing I could about you.
That's what I was gathering. Well, thank you for having me here. I have to apologize, my Portuguese is not very good. Those who heard me yesterday know I have to speak in English. I should say I will make the talk in a way that you can interrupt me all the time. And we can have a discussion during the talk if you wish so. So you should not be afraid to ask questions in the middle of the talk, as you wish. I should also apologize to those who already heard me speak yesterday. There's going to be some overlap. We don't have that many data. But today the focus will be on the role of virus infections and type 1 diabetes. And we will discuss in more detail the evidence as to what role in the pathology of type 1 diabetes virus infections could have. And maybe also some future studies one could base on this to prove or disprove that there is an influence of virus infection in type 1 diabetes. That will be the major part of my talk. And then at the end of the talk, we'll talk a little bit about combination therapies, and those who heard me yesterday can go to sleep during that part today. And then we can hopefully have some time for discussions. So the situation with virus infections and type 1 diabetes, and you will see this from the data I show you today, that are mainly from animal models, but also some human data, is complex. In animal models, and this is why I put this question here, one can show that virus infections can accelerate the process leading to type 1 diabetes, but one can as easily show that virus infection can stop the process leading to type 1 diabetes. So this type of experimental evidence, which you will see in a bit, leads to a very complex situation epidemiologically in humans. Because we do not have at this point enough insight and enough data to decide what makes a virus infection an infection that propagates diabetes and distinguish this from a virus infection that stops type 1 diabetes. Of course, mechanistic knowledge and ideally biomarkers about this situation would help us greatly, because we can then devise strategies to prevent those virus infections that accelerate the disease or promote the disease, or we can have strategies that allow us to be more permissive about virus infections that have actually positive effects on type 1 diabetes. When you see the data, you have to keep in mind several issues that are not resolved. And viruses are tricky beasts. They can do many things. One issue is whether the virus infection has to occur in the pancreas or target organ to have one or the other effect. This is one issue that is not resolved, and we don't fully understand this. So is a virus that infects beta cells or the pancreas more likely to promote the disease, whereas a virus that infects elsewhere is less likely? We don't know that. It might not be true. The other issue we have to keep into account is that virus infections can grow on an individual basis to different titers, and this varies greatly. So if I get a virus infection and transmit this virus to any of you might grow much smaller, much bigger titer, and I might not be sick, or you might become sick. This is not entirely predictable. For some infection, it's more predictable, but for example, for enteroviruses like Coxsackie B viruses, there's a huge variation. You can get a respiratory syndrome, commonly get gut infections. This can be very mild, it can be very bad. These things can vary greatly. That might at the end be a deciding factor as to whether you become sick and you promote diabetes or you don't become sick. And it might have similar implications for heart disease and so forth, and so on and so forth. The last issue we don't know for sure, and one can draw interesting parallels to other diseases, is the issue of persisting antigen from the virus. So the question, whether the virus has to persist in the beta cell, or at least whether you need repeated exposures to the virus or pathogens, as this is the case for some of the autoimmune heart diseases that are very well studied here. We don't know that for a fact either, and related to that is whether the virus infection has to occur in the target organ or whether it can be a peripheral site. So we go through the evidence in animal models that might help make some of these decisions, because in animal models you can resolve some of these issues, obviously. I want to put in the beginning, just as a baseline, what we know about type 1 diabetes in humans. We know very certainly it's an autoimmune disease because of these old pancreas transplant studies, and that's important to understand that. So what Sutherland in this case has done, he's taken pancreatic from one twin that had no diabetes and put it into the twin that had diabetes with the goal to treat the disease. And after 6 months, the islets were gone. So there was a good memory in terms of autoimmunity. And we also know that there's antibodies to islet antigens in type 1 diabetes. And these two factors together make it rather certain that the human disease is an autoimmune disease after all. So that we know pretty well. There's other things we don't know, and they are of relevance to consider the role of viruses. We don't know what really causes type 1 diabetes in humans. The genetic makeup has been well studied. We know that genes contribute to a large extent to the susceptibility of the disease, but it's a polygenic disease. There are many genes acting in concert, so it's complex. The biggest region that causes diabetes is the MHC region, but even there we do not know what parts of the MHC region, which is rather large, predispose to diabetes. Well studies are HLA class 2 molecules. We don't know at this point well about class 1. Although class 1 would restrict killer cells, and killer cells are good candidates of killing beta cells in humans. So that's also not known. What is known from also similar twin studies like the ones where Sutherland has profited from is that there's a heterogeneity between the disease penetrance in monozygotic twins. And that argues strongly that there's an environmental influence for the disease. And there again, we don't know much either. It can go from nutrition to viruses and so forth, but there hasn't been any single factor that has been identified to cause the disease. Historically, people have argued that the incidence of diabetes is higher in countries that are in the northern hemisphere, Finland, Canada, and so forth. Similar for MS, there's well-documented studies. And certainly it's well documented that